Okay, so good morning. Thank you everyone for joining us for this webinar toward advanced bio-based composites for sustainable industry. My name is Thibault Lefort and I'm a project manager working for Polymeris, a partner of the THERMOFIRE project, which is hosting this event. This webinar is organized in partnership with ALCHEMISSTS, BIO-UPTAKE, BIONTIER, FURIOUS projects, all European projects that work on bio-based composite solutions through different approaches, applications that will be presented to you. You have here all the partners present in this webinar and workshop. Just to make the webinar as smooth as possible, I will ask you to please keep your micro and camera switched off by default. If you have any question, use the questions box at the right of your screen during the presentations, and then we will be able to compile them and answer them during the question and answer sessions during this webinar. And of course, the support of the presentations of each project will be sent to you at the end of the event. Just a reminder of this of the agenda of this morning. As a first step of this workshop, we will introduce you to the main principle of standardization and its benefits in research and innovation projects with the presentations of FUNE with Elena Gaillot. We will then offer you an overview of the partner projects, ending with the focus on the issues in relation to standardization, and we will then continue with a roundtable discussion on the challenges and advances brought by each project on standardization. And then we'll conclude with an interactive workshop moderated by MNLT with Nikolaos Sigas and Alexios Vasiliki. If it's okay for you, let's begin with the first session of this morning with the presentation of FUNE. Elena, I think the floor is yours. Just
yes,
use the right
yes,
present.
Yes, please. So let me. Okay. So good morning. Yes, it's okay. Perfect.
It's okay.
Good morning, everyone. I'm Elena Gaillot. I'm working in UNE in the Spanish National Standardization body, and we are partners of BIO-UPTAKE project. I am going to present the general ideas of standardization and the relationship with R&D results. So the index of my presentation first, I have an introduction to standardization, the general concepts, and so on. Then we talk about the benefits of including standardization in R&D project. And the last point of my presentation is how to develop a standardization document from R&D results. So standardization, the first thing is to know. I'm sorry. I'm there. Perfect. The first thing is to know what is a standard. A standard is a technical document designed to be used as rule, guideline, or definition. A standard is a voluntary document, but its use is highly and widely recognized. Standards usually are not mandatory, but can support the legislation, and this is one of the most important characteristics of a standard. And usually, a standard is produced in the framework of a standardization organization. by all interested parties in a transparent, open, and consensus-based process. Related with the organizations that work in the development of standards, there are three types of entities. In the international level, there exists ISO, that is the standards or international standard organization that works usually in items related with materials, procedures, and so on. IEC, that is the body who works in electrical issues, standardization in electrical issues, and ITO, that works in telecom issues. In the European level, there is CEN, that is the body, the standardization European body, CENELEC, that is the same that IAC is the entity that works in electrical issues, and ETSI, that is the body that works in telecom issues. And also there exists a number of national entities. Here you have some of them, and all of us, all those national entities work on one hand in national standards, but also in the development of international or European standards by means of different collaboration with ISO and CEN. All those entities have the same European and national regulation. There exist international agreements in order to organize works shared among different entities. All of us follow the same common rules of work, and there exists a linked participation. I have here a general scheme of how to develop a standard. First, we need some stakeholders define a market need or a policy need, and also those stakeholders have to decide to collaborate in the standards that will solve that need. This need is developed in the frame of a standard development organization. For do that, there exist technical committees. Each technical committee working on a specific topic, and different voluntary stakeholders work in this committee, developing the standards that could solve those needs. Usually, all technical committees have the same common rules and works in transparency, reliability, and reconnection procedures. And the main objective of those groups is work until reach a consensus in the content, in the technical content of the document, of the future standard. As when this consensus is reached, we have defined a standard that will be published by the standardization bodies. The types of deliverables of standardization documents that are still are the next. First, the most typical is a standard that are documents that are called EN, ISO, or something like that, or at national level DIN standard or UN standard or something like that. This is the top level document and requires the full consensus for the publication. The second type of document is a technical specification. Technical specifications are called THEM TAs or ISO TAs. In this case, less consensus is required for the publication of the document. And in this case, those documents have a limited duration, usually 6 years. Other type of document are technical reports that are called THEM-TR or ISO-TR. In this case, those documents don't include requirements and are informative documents. And finally, the last type of document is a workshop agreement. A workshop agreement in THEM are called QA, are in ISO are called IWA, and also exist workshop agreement at national level that are called specifications, in spec or specificación UNE or something like that. In this case, those documents require a very reduced consensus and have a fast-track process for elaboration. And those documents are the ones typically used for standards coming from research and development results. Those are the documents we draft in the frame of R&D projects. Related with the topics, well, there exist standards about many different topics. You can find, I think, standards related with a lot of different things, and the standards could be related with test methods, services, products, or definitions. Related with the benefits of including standardization in R&D projects, first, very important, standards ensure compatibility and interoperability in the process. So it is important all different actors in a specific area follow the same procedures in order to make comparable the results. Standards help to achieve better levels of performance, reliability, and quality, helping to make a process, service, or business successful. The use of standards optimize the organization management and services provision, leading to a reduction of production time and cost. Standards build trust among stakeholders in the value channel. Use of standards contributes to disseminate knowledge and to facilitate the application of technology. And this is very important in the frame of a R&D project. Also, standards facilitate the access to market and the organization operation in the countries, and standards can support public policies, legislation, and regulation, and ensure the products and services fulfill the requirements. And here there are two links about the, well, there are recommendations from European Commission about the production of standards and the use of standards in legislation. In the case of R&D project in Horizon Europe, there exists a number of calls that explicitly request standardization of a task in the project, and also include a specific indicator in every project, an indicator related with the standards. The way we work in the European project in order to develop that task of standardization is usually we try usually to develop specific standardization documents that always will be QAs, the standardization documents that better fit with research project. But that is not the only task we develop. We usually also prepare reports about the use the existing standards related with the topic of the project and other things related with the development of QAs. I think, well, this is on one hand, I have included the procedure established by SEN for developing a QA, and also I have included some recommendations that we usually apply in the project we participate. First thing is related to the concept. One concept is a Zen workshop. A Zen workshop is a working group, a temporary working group, not an event. It's the working group we have to organize or develop a standardization document, a QA. It's very important because this working group is open to the participation of any interested parties. That is very important in the frame of a research project because in this working group, of course, in the development of a standardization document, can participate entities that are not partners of the project. And the other important concept is a Zen workshop agreement. The Zen workshop agreement is the document, the deliverable we produce in the frame of a Zen workshop. It's the, as I said, the type of standardization document that well fitted for emergency knowledge and needs a very reduced consensus from for the publication, and it have a very fast process elaboration and a limited duration of 6 years. A standard coming from a research project is published during a maximum of 6 years, and after that is deleted. Here you have the link to the guide, the Zen guide, where the procedure for the redaction, the elaboration of a QA is included, and the reasons for preparing a QA in a research project are impact, because those documents recognize reference documents published out of the consortium, agility, because there is a fast track process for develop those standards, openness in a process and visibility to all market players, sustainability document to cover new knowledge. The standard can test different solutions in the market and can be the first step towards a future EN or ISO standard. And this is the type of standards we could prepare depending on the level of the results we are working in. When we are working in tier level low, 1 or 2, we usually prepare standards related with terminology, and when we have tier higher from 8 or 9, we usually produce standards on product services. But the most important thing here is that a very important part of the research project can be transformed in a standardization document. This is the process for draft a document. The first thing we have to do is the preparation. During this preparation, we have to to nominate a chair of the working group. Usually the chair of the working group is a partner of the project, is the partner that has promote the elaboration of the standard. Then we have there is a secretariat. The secretariat is always a national standardization body. This national standardization body could be a partner of the project. For example, in BIO-UPTAKE project, we are partners of the project, and we participate in the workshop agreement as secretariat. But if there are not a partner, a national standardization body in the partner of the project, this activity can be subcontracted by a tender of call or offers. And also, we need some experts that could be partners of the project or not, participate also in this working group. In this phase of preparation of the proposal, we have to develop a self-assessment of the future CRUA. We have to prepare a description of the standard we want to prepare, that usually is made by a secretariat, but plus the proposer. We have to analyze if there exists some sensible topic in this proposal, because if exists, the decision to go ahead with the proposal depend on the bureau. And we also have to check if there exists any overlapping with technical committees. For doing that, the proposal we submit to CEN has to pass a 30 days consultation period. If after this public consultation period there are not overlapping, we can start the process of drafting. But in case there exists a conflict, the decision of drafting or not the document also belongs to CEN-CENELEC Bureau. Next part is launching. Launching starts when we pass the assessment, self-assessment process, and there are not conflict. Then we have secretariat submit the documentation to CEN-CENELEC, and a 50 days public announcement starts. Then put the proposal in the web page and start a period of public comments, public comments to the document we have prepared, and also announce the kickoff meeting, the date of the kickoff meeting. And after this period of public announcement, we celebrate the kickoff meeting of the project. In this kickoff, this meeting is open to any entity interested on the topic of the document. And the objective of this kickoff meeting is present the technical content of the future standard, appoint the chair and the secretariat, and start to the drafting work of the document. The participation in the working group is open to any entity interested, but participants have to submit a registration form completed for participating in the workshop related with the property, intellectual property rights. The property of the shared knowledge belongs to the owner, and the property of the published document, the published QA document, belongs to CENELEC. And after the kickoff meeting, we start the drafting process, and this process finishes when all the participants reach an agreement about the content of the document. Usually work by online meetings or sharing different documents by email or something like that. And when the participants in the working groups agree the content of the document, we have to inform to relevant technical committees about the document and start the last phase in the development, that is the public web consultation of, again, 30 days. This public consultation is optional, but then recommended to pass it. In this consultation, we share the document with general public, through the website, and any people interested can submit comments to the document. At the end of this period, the working group have to take resolutions about the comments we have received and prepare the final document for publication. And during the publication phase, Secretariat sent the final draft to CENELEC, and CENELEC published the document. Usually, the documents, the QA documents, can be downloaded from CENELEC website free of charge. That is because usually the projects pay an amount to send for use that option. And here, well, this is the CENELEC website and the list of project of standardization results coming from R&D project available for download. This is the link to the web. And related with the promotion, well, we usually promote the documents through social network, different news in project channels and other channels we can use. And related with the maintenance, the documents are published for 3 years. After 3 years, we have to decide if we prefer maintain for other 3 years the document, that is the confirmation of the document, review the document and improve the questions we need, or withdraw the document. The other option is to convert that document into another kind of standardization document, an NN or something like that. And if we decide to confirm the document will be published for 3 other years. And after that period, the document are also always withdrawn. And well, this is the timing. The timing depends on very different things. The most complicated phase is the preparation, because not always is easy to identify a result that could be transformed in a standard. And in many cases, partners don't want to produce a standard, because that means that this knowledge is public, and accessible to everything. And in many cases, it's not possible to share the information. But well, if we can identify those results, usually the period for doing all the process until the publication of the document is minimum 3 months, and usually between 6 and 12 months. And this is my last slide, I think. Examples of usual topics we can produce could be terminology, test methods, methodologies, criteria or indicators of the different procedures, or product specifications. The source we usually use for identify potential documents are deliverables of the project. In many cases, we use the deliverables as part of the deliverables. We usually don't need as many information as partners include in a project deliverable, but part of this information is very useful for defining a standard. Also, papers produced by partners, papers related with project results or congresses proceedings. And in other cases, we define a general theme for working, and usually research groups participating in the project complete that information with other, I don't know, doctoral thesis results or something like that, and produce the final document. Important. We cannot include safety aspects in the documents, in the standardization documents, because it's forbidden to include that. And it's important to avoid sensible topics or conflict with existing technical committees, because in those cases, the decision to produce or not the document belong to CENELEC direction groups, and that consume a lot of time until the decision. We have to spare the meeting of CENELEC and so on. It's a very confusing procedure. And I think that is all from my side. This is some links, useful some links related with the development of QAS and the participation in research project. For example, this link is very important because it's specific of standards in research project and the relationship with standards and innovation. And I think that is all from my side.
Thank you very much, Elena, for this very interesting presentation. It lays the foundations for this webinar on the standardization, I think. I don't have any question in the chat, but I think we will be able and have the opportunity to come back to this through the webinar. Of course, don't hesitate to come back to Elena after and or ask your questions. We still have some time to answer it. Does a partner, maybe a project partner, have a question for Elena? Or we can switch to the next session. Okay. So let's move to the next session with a thank you, Elena, with a quick overview of our European projects and how they have to deal with the standardization. We will begin with the BIONTIER project. I don't know if Tatiana managed to with this is her micro. I can't see you, or Yusuf maybe.
Yes, yeah, she's in another parallel workshop, so
Okay.
I'll take on behalf of her.
No problem. I'm giving you the rights to present. I think it's working. No.
Not yet.
No, I think it's all right.
Now?
Okay. Yes, we can see your screen.
Yes. Do you see the screen?
Yes, it's working. Perfect.
Yeah. Oops. Oh. Yeah. So this is the European project BIONTIER. This is mostly aimed at developing new generation of multifunctional, lightweight, recyclable, and sustainable biocomposites. And the main aim here is to bring in some advanced functionalities or functional properties in terms of thermal, mechanical, chemical resistance, and the ultimate aim is to go at a higher TRL levels for practical applications. It stands for breaking frontiers in sustainable and circular biocomposites with high performance. And it's a 3 years project starting from 2024 until 2027, led by Fourth from Greece. And the main application here are divided into 4 major objectives, mostly sustainable and circular design, innovative sustainable materials, manufacturing technologies and prototyping, sustainability assessment, and end-of-life management is another major aspect here. And ultimately, how to create the awareness and market adoption of the technologies and composites that will be developed within the consortium. And here, the ultimate aim is to bring everyone under the one umbrella for the industries, SMEs, research centers, and academia too. And in terms of standardization, what we are going to work in this is still the activity that is to be started in this project, but the ultimate aim is to work very, very closely with the EU level, national level, and local institution level. For example, it was CEN was already mentioned in earlier keynote presentation, and also go further on European Bioeconomy Standardization Coordination Group, national standard bodies related to respective countries, and work on the standardization and follow the progress around that. Another major aspect is that it will be emphasized is to see the analysis of the applicable standardization landscape, because we will probably discuss this in the subsequent brainstorming. The main issue is there are not many standards related to biocomposites directly. There might be for individual materials or for the final composites, but not for the novel composites being developed around in this aspect. So, and the other main aspect will be at the end of these activities to give some key stakeholder recommendations to the stakeholders, that how do we challenge these, address these challenges and deficiencies in existing policies and regulations at the national and EU level. At the moment, I think we already discussed earlier, we have CEN, the European Committee for Standardization, and there are a range of working groups that we have been looking around and digging around, which are mostly related to bio-based products, related to a range of materials. It can be from different isotope ratios to, and it leading until the end life cycle assessment too. So there is a lot of work going on in the working groups, but still a concrete activities related to standardization of bio-based composites is still needed. At RISE, and we had one related white paper that was in 2023, which you could read on the given link here, which also gives a bit of more information, or let's say guidelines towards the recommendation to the stakeholders. And we would encourage you to look at this white paper. And the main aspect that we should probably consider, or which is still to be considered in this kind of task, is that raw materials characterization, performance testing, end-of-life standards, and ultimately the LCA, from either it could be cradle to grave or until from the manufacturers to the users. And the major issue is that there is no harmonized standards yet. As I mentioned earlier, there are working groups, discussions, but there are not really harmonized standards for natural fibers or effect of mechanical and environmental aspects on biocomposites or biopolymer-based materials. And performance testing of biocomposites is important, where also in BIONTIER is going to target structural health monitoring, sensors for structural health monitoring, and other aspects. And another major thing is also the end-of-life standards, because we might have standards for raw materials, for final product, performance testing, but also standards for end-of-life, and also sustainability aspects, LCA, until what level we should go into the LCA, and these things are very crucial. So those are the things that BIONTIER is going to target. So I spoke on behalf of our colleague Tatiana, who is mostly going to handle standardization aspect, and I myself am Yusuf Bolla. Yeah. Thank you. Hello.
Thank you.
Hello.
Thank you for the presentation of BIONTIER. Nicola, does your micro work? No. Okay, we'll manage it. Okay, thank you. Let's move to the next project, ALCHEMISTS. ALCHEMISTS with Carlos Fito. Does it work?
Maria Rivero.
Ah, sorry, Maria. I'm giving you the floor. I think it's working.
Can you see the presentation?
Yes.
Okay.
Not the presentation, another screen.
Okay. Let me.
Yes. It's coming.
Is what are you seeing? Is in full is in presentation mode now?
No, it's the PowerPoint.
Sorry, I don't know how to do it then.
I think you can switch. Yes, it's the second screen that we have here.
I am very sorry. So, what now?
It's still the second one. And,
but I have the same in the two screens. So
okay.
I don't know.
Maybe do it
can you switch to the next project, please, and I will try to fix it. Sorry.
Okay. Maybe you can switch it in PDF. It's easier. Let's switch to another project, THERMOFIRE. Elvira.
Hello.
So when I have the possibility to share this.
Hello.
I'm giving you the right, Elvira. It's working, I think. Yes.
Yes. Can you see me maybe now?
Yes, that's working.
Okay. So I can maybe close this one. Okay. So can you see the screen, I guess?
Perfect.
Okay. Thanks to all of you for joining us today. So in behalf of BIONTIER, we are the coordinators of THERMOFIRE project. This is a project funded by the Circular Bio-Based Joint Undertaking in Partnership. So we are very happy. We are more or less in the half of our project, a bit further. And we are focused on the development of bio-based fire retardant thermoplastic composites reinforced with natural fibers. So the aim of the project is to have a 100% bio-based composites with an adequate flame resistant for different sectors. So as overview of the project, we are leading 12 partners, 12 entities across Europe. And our goal is develop 3 prototypes at tier 5, for automotive, the housing for the electrical batteries. For aerospace, it's the back part of a seat in an aircraft, and textile. In this case of textiles, we are developing thermoacoustic isolator panels for building or for automotive. But the final goal of this is to remove at the end the European dependence of fossil-based and also the dependence of some of our additives that we are using for flame retardancy. So as you can see here, we have a contribution here to 4.5 million. And what we are using as feedstock, it's natural fibers. For example, we are using flax fibers. We are using a 100% bio-based polyamide 11, and we are using 100% bio-based flame retardant. I'm presenting some results, and I have to say that we are not able at the moment to replace one traditional flame retardant, for example, if you think in one halogen-based, by one bio-based. What we are doing is develop synergistic mixture of different bio-based materials to achieve the performance that the sector needs for the flame retardancy. So as I tell you, we are using different technologies for these 3 different demos that we are doing. In case of the back panel of the aircraft seats, we are developing pre-preg materials. In case of automotive sector, we are doing by injection molding, uses this polyamide 11. And in case of textile, we are using a special airlight process to make these thermoacoustic insulator panels. We are 12 partners in a total way, most of us in the Mediterranean side. So we have Canoe, and Safran, and Arkema, Natureplast, and Polymers developing the plastic part of the project, and we have for the demonstrator CRF, Geopanel, and Safran working from the demonstrator that we are doing. In the part of the standardization, my colleague Nicolas is connected from NMLT, who is talking about the standardization that we are aiming in the project. I wanted to show you some photographs and tests that we are doing in some materials. For example, these materials are prepared for the battery housing. We have to be honest, when we initially started the project, there was not a specific standard for this material. As Yusuf mentioned before, typically we go for a standard for the component because there is no standard for testing these materials. So this is some tests that we are performing with the idea is a flame retardant standard focused in retardancy, not in the reaction of the material. So this is not, this is testing the over temperature, which is supposed not to be over 300 degrees when the flame is applied at the back part. This is because we think that in the automotive, it's supposed that the battery box is going to be placed on the under the vehicle space. So it's supposed that if it's suffering some burning, the passengers should have some minutes to escape. So the temperature above in the top face should not be over the 300 degrees. But one thing that we have in our testing is how we do this test. Is applying the UL94, is applying the FAR 25, other ones for automotive, is applying Eurocodes for building. How we prepare the samples is influencing. So there is a lot of questions, and typically the standard that you find is not fulfilling your needs. So this is an open question. Okay. Some other results that you can see here, it's 100% bio-based fiber and bio-based sizing of the fibers to give the flame retardancy that we need to prepare the composites. Also here in this way, you can see 100% polyamide 11 reinforced with natural fibers and with bio-based flame retardant. And in case for the materials that we are going to produce the prepregs, you can see this kind of materials. So as conclusions, we are happy more or less at the half of the project because we are achieving more or less our objectives at a smaller TRL. We now have to upscale, but we say, okay, we have achieved the maximum category, but this is enough. We know that we can contribute to the society and to environment, reducing the CO2 emissions, removing the European dependence on some fossil base for the materials, the polymer, and the bio-based flame retardant additives. But we still face the problem to say what barriers we have for standardization. The cost of testing and the time. I acknowledge to Elena to explain so nice the process that it's necessary to have a new standard. We also have the lack of standards, as Yusuf mentioned before, but the lack of stable and homogeneous suppliers, lack of maybe early adopters who is pushing for this. And one open question, if all the regulation or policy is helping this research and develop action, or is stopping it because we are not so clear in which we have to develop. So I think it's a lot of questions. I'm stopping here with this presentation, and thanks to all of you for your attention.
Perfect. Can you hear me now?
Yes.
Okay, great. Now it's working. So I will now let the floor to Alchemist with Maria. If you can go back to you.
Okay, let's try. Are you looking to my screen now? No. Yes. So. Now?
Perfect.
Is it okay?
Yeah, it's perfect. Thank you.
Okay. Sorry for the issues from before. So
right.
Good morning, everyone. My name is Maria Rivero from ITENE. ITENE is a technological center based on Valencia, Spain, and we are coordinating the European project ALCHEMISTS, which means I have lost the screen now again. Sorry.
No, I can see at least.
Wait.
You see your screen? Yes.
Yes.
Okay. Sorry. With alternative chemicals and materials, integrating safety, sustainability, new production technologies, and socioeconomic aspects. The main goal of the project is to demonstrate the applicability of the SSBD framework in real industrial environments. For such purpose, we are working on 3 different value chains: surfactants, plasticizers, and flame retardants, and a total of 7 case studies or demonstrators. So we are a consortium of 27 members or institutions from different countries all around Europe, and the projects last a total of 48 months. We are just recently completed the first year. As key objectives, we have to develop new safe and sustainable by design driven alternatives within surfactant, flame retardant, or plasticizer functionalities. Generate evidence and documentation for a proof of concept of the applicability of the SSBD framework, develop a SSBD certification methodology to promote this implementation, implement integrated approaches and tools to support safety, sustainability, and social assessment based on interpolable fair data models, and demonstrate the application of the SSBD framework to this innovation alternatives. For this occasion, we have focused on the flame retardants value chains, as it provides clear examples of the standardization challenges inherent in implementing the SSBD framework. We are working on the substitution or at least reduction of the highly toxic flame retardants components like antimony trioxide or medium chains chlorinated paraffins by phosphorus, nitrogen, or carbon-based compounds in organic salts or bio-based additives. As you can see, we are covering all the life cycle of the new alternatives from the production, scaling, formulation, and finally validation or demonstration. The use cases will be safety boot salts for firefighters and insulation foams used in the construction sector. Now, to continue, I will ask Elvira from Avanzare. Avanzare is the partner of the project in charge of these value chains, and she will probably be able to explain better the issues or the challenges we have found in the implementing on this standardization.
Yeah. Thanks, Maria. Just in a short overview, one of the typical traditional flame retardant is antimony trioxide. It's not only because of the hazards, it's now a problem of price and stock in Europe. We have an important dependency mainly from China for this supplying, and both for the soles, because it's widely used for rubber, and as well as insulating foams. It's very easy, it's not so easy to replace because this material is working with very low amounts. So one of the challenges that we have is not only be able to substitute the material by another one, more safe and with better availability in Europe, but also without changing the rheology, the vulcanization, and the other performance of both soles or foams, and in case, especially in case of foams, not changing the thermal conductivity as you refer in the table. So as well as in the other sectors, we are using or we are trying to fulfill our products applying standards which are referring to the final component. In the case of firefighters boots, there is a specific test, or in the case of the insulating foams, we have a specific tests for these ones. So it's a big challenge, not only replace, but also fulfill all the requirements, the technical requirements that these two demonstrators have. So if you want to continue, as barriers, we have a lot of difficulties to test these advanced materials by reliable ways. And we, in most part of the cases, we are missing a lot of raw material information. For example, when we try to do some kind of safe and sustainable by design analysis or LCA, LCC to understand the sustainability, we don't have some material information. So it's very, very difficult for us. And the other big issue that we have is the time and the cost. We at Avanzare, for example, and I think all of SMEs are in a very similar situation. It's very time consuming, and of course it's a high cost that we can collect all this data, analyze of the material, testing different matrices and so on, while we don't have a very good certainty, a very good understood of the landscape that we have today.
So I think this is all from our side. Thank you very much, and thank you, Elvira.
Thank you, Maria.
Thank you, Maria. Thank you, Elvira, for this presentation of ALCHEMISTS. I think we can move on to the next presentation with Deborah from FURIOUS, if you're ready.
Yeah. Let me see.
I'm giving you the rights. Yes, we are you.
You see my screen?
Yes.
No, not me.
Oh, sorry.
I can see it. So yeah.
Oh,
Yeah, you can start.
okay. I do not see my screen. You see? You see my screen?
No.
No?
No.
Why not?
Not yet.
Not.
But it was okay before, so nice, good. Yeah.
It's working.
Now?
Yeah, perfect. You can start.
Why? I don't know why it is appearing. Sorry. I don't see my slides. Sorry.
I think you're going on full screen, and so it disappears for you. But for us, it's okay.
But I don't see. I'm seeing the audience. If you ask,
Maybe you have a possibility to open your presentation in parallel, and we will somehow. So you
Deborah, do you want me to share your presentation?
let me see if I can do it. I don't know why.
I think it would be easier, Thibaut, if you share your screen and then.
If it's okay for you, Deborah, I'm sharing my screen with your presentation.
Sorry, I'm really sorry about it. Thank you. Thanks a lot.
I think it's working. Okay, is it okay for you?
Yes, thank you. Thanks a lot.
Perfect.
So sorry for this delay. Well, I'm showing what we are doing in the FURIOUS project in the frame of this RIA project that started in 2023 in parallel to the THERMOFIRE project that was funded with the same call. What we are doing in our FURIOUS project is try to use this new monomer that is the 2,5-furandicarboxylic acid. The partner in charge of providing us this monomer is the company Avantium, the only one able to provide this in Europe. And we are a group of 15 partners working on 2 scales, the lab scale and even the upper one. So we are moving from the design of the polymers at the lab scale, and we are providing 3 different sectors of application. So the different companies and the universities are collaborating to cover 3 different sectors. So he goes with the next one. Thank you. We are trying to use different approaches in the studies. So we want to make not only homopolymers, but even copolymers and blending by using reactive blending of FDCA bio-based polymers. And we are trying to use not only standard processing conditions, so not only injection molding, gas blow, extrusion, but also other unconventional, let me say, methodologies. Oh, sorry. We are going to use electrospinning and stereolithography. As end-of-life option, we want to try to test the recyclability and the end-of-life in terms of compostability, biodegradability in different environments, such as the marine one. What we we are going to do is to use a pre-treatment that was never tested with biopolymers. So we want to include pre-treatment by gamma radiation to increase the possibility of tune the end of life for these materials. So what we would like to find is a real alternative to the only polymer based on FDCA that is now on the market. So the PEF polymer, the polyethylene furanoate. Next one. The prototypes that we are going to produce in our project are two prototypes for the biomedical and electronic packaging. So we are moving far from the food packaging sectors, and we need to find very good performance, and we already find them to water and oxygen barrier. So what we are doing now is trying to verify the sellability of our flexible packaging, but we are already ready to scale up. We are just in the middle of the project, and we have material to be scaled and processed at the company level. Then we want to produce a filter for the automotive sector, and in parallel also an injected molded screen to be used in a caravan. What we are going for, looking for properties strongly related and essentially related only to the chemistry of the polymer. So we want to avoid any kind of additive, nanofillers, or everything that could alter the end of life of our materials. And it's not easy, because if we want to cover, for example, the automotive sector, there are a lot of standards that need to be checked, especially for the fire resistance. Then the last application is the one for the underwater environment. So we are developing a biosensor to check the environment in the presence of different microorganisms. Then we also develop an optical fiber made by using an elastomeric polymer. It works like an optical commercial fiber, so we are working on it, and we are really happy to reach. We already reached this goal, and it is nice for the market. So we are proposing a material that can be degraded in the sea and works as a, let me say, standard PMMA optical fiber. Then we want also to use an elastomeric gripper to substitute the one that are now being used that are not biodegradable, with the main goal of reaching the reduction of the emission, and also to try to recover the material, to repolymerize the monomer itself, and in line with the requirement of the LCA LCC request. The next one. There are some gaps that we have already identified in our project. We have no working groups working on standardization level, but we already identified that there are some problems to cover and to try to expand the application in the market. So, for example, it's not so, maybe it's far from the standardization, but one issue is that, for example, we have FDCA REACH registration, but up to now there is no polymer derived from FDCA that is already commercially available, but is not in the list. It's a safety issue, so I understood that this is not an issue of the standardization, but in any case, maybe I don't see the.
Thibaut, you have to change. Sorry.
So we should look for terminology in this case and for safety of polymers from FDCA. One issue I think is also there is no quality assessment for food waste. In our case, we're using sugars. Maybe there are some regulation about how to make biofuels from biomass, but how to make biopolymers from waste material, I think there is no standards associated to this, being that is food waste. We are in the CBE, we are using waste in our project. Another issue, I think, is the how to apply the medical standards that are now usually considered for standards materials, let me say for polyolefin or gamma resistant materials to the bioplastic sectors. To the best of my knowledge, I think there is no point in the standards covering the use of biopolymers in the biomedical packaging, at least for the sterilization. There are no standards for biopolymers to be used in the underwater sectors. So there are some standards for some specific biopolymers, for example, polyhydroxyalkanoates, but I think there are no standards for marine degradability of FDCA or food waste related biopolymers. In the case of automotive, I think this is a very critical issue since the sector needs a lot of requirements, and maybe it's not our case with the electrospan, but we need to cover only the request of the filtering efficiency and the quality of the material, but we are not sure at the moment that the absence of nanoparticles is confirmed. So what we should do in the case of use of additive as in the case of nanoparticles. And lastly, I think we should try to harmonize the recycling and composting protocols. These are so different at the country level, and there are not so many standards that are common to the different countries. And this is an issue, I think, for all of us that we are here. And that's all for Furious. Thank you for helping in the sharing.
Thank you, Deborah. I think we already started to discuss about the subject on the roundtable, but that's good. I will now let the floor to BIO-UPTAKE. Robbie, if you can share your screen.
If you could give me the rights, I think.
Yeah. Thibaut will do it.
Okay.
It's okay.
Can you see my screen in presentation mode?
Yes.
Yes, perfect.
Okay. Perfect. All right. Good morning, everyone. My name is Robert de Bisschop. I'm a researcher from Syntexville, and I will present the BIO-UPTAKE project as well as one CWA that has been done, and I'll give the word to one of the other partners who will also present their CWA into the project. So BIO-UPTAKE is about biocomposites in smart plastic transformation processes to pave the way for large-scale uptake of sustainable bio-based products. So before we start, here's an overview of the partners that we have. So 14 different partners, also industries and product users are in there together with some RTOs, academia, and others. So what do we do in BIO-UPTAKE? So the objective here is to have a sustainable uptake of different bioplastics composites through boosting twin and green and digital transformation in the European manufacturing industry, because the problem that we have is the petroleum derivatives cannot be directly replaced with the bio-based materials. So the solution that we are doing in BIO-UPTAKE is to create a smart combination of intermediate formats. So this is the filaments, tapes, and pellets, and then develop the manufacturing processes that are needed to use these biomaterials instead of the petroleum derivatives. Some specific objectives you can see here. So we have, let me, can you hear this? Okay, I'll just. Okay, so we will develop 3 different manufacturing processes for the 3 different type of demonstrators that we want to make, and therefore we will adapt and upgrade 6 manufacturing technologies and also develop 4 bio-based intermediate formats. We will therefore make 3 different manufacturing value chains. You can see them here in the middle. So the first one is construction, the second one is for medicine, and the third one is for packaging. And both of these end products will have more than 75% bio-based materials. And on the other side, we will also have a digital end-to-end platform for these bio-based materials and as well contribute to the standardization. Therefore, also this workshop and the CWAs. So the general objective is to ensure a sustainable uptake of bioplastic composites. Therefore, we need to have these flexible manufacturing processes for these specific bio-based end products because they cannot be directly replaced. Now, if we look into what are now the demonstrators that we make and how are we making them, what are the intermediates? So here you can see for the first one, we are starting with PCL and PLA materials. We at Syntex will do the film and extrusion of these, and then we send the materials to the partner Comfil, who will make the organo sheets and thermoform them into this first feed insole demonstrator. Then going to the second demonstrator, again, we will use the organo sheets produced by Comfil, but we also incorporate materials pellets from ITIP, who are made from biopolyamide and also wood and short carbon fiber. Then together with specific polymers, they are using the reversible adhesives, the cans, into this. And then Moses will do the over-injection molding for their demonstrator. And with these reversible adhesives, they can also be, again, separated. And the idea is to also recycle both of them separately. The third demonstrator also uses the same idea of the CAN, so the reversible adhesives, but here together with bio-epoxy and flex fiber, where Sidetech will do the resin impregnation into organo sheets, and then the thermoforming will be done by Potcom to create these bedroom pods. Here we can see an overview, and then lastly, at the end, we also have some inline monitoring, product simulation, digital platforms specifically for these bio-based products by Iris, Simcon, and Amen, and then also some standardization, dissemination, etc. done by all the other partners. Now, this was a short introduction into BIO-UPTAKE. Now we'll go over into the specific standardization CWA that has been going on already, or the first one of them, which is by us at Syntex, and together with Elena, we do this CWA. So this is about the development of the reinforced fibers based on bio-based materials. So for the first and second demonstrator, we use these fibers to create the organo sheets, and these fibers are bio-based materials. So we are doing here self-reinforced PLA, where we use a low melting and a high melting PLA grade together, where they will be incorporated together, and the high melting grade will form really the reinforcement of the composite, while the low melting grade will form the matrix material. There's 2 ways to do this, but I will go not too technical into this process. Now, how we are making these filaments, what is the CWA actually about? Well, this is actually in the way of how we produce the PLA filaments. Normally, this is a multi-filament process, an FDY process, which is fully drawn yarn, where we draw the filaments in a solid state drawing. As you can see here on the image, we draw it in a first stretching, second stretching, third stretching, and then the only last roll, we have a relaxation roll. This relaxation roll is to have a lower shrinkage, or to try to have a lower shrinkage. We make very high tenacity and high modulus yarns, but we still have a problem with the shrinkage. You can see on the image right here that the frame is fully bent when Comfeel is producing these filaments into organic sheets. It is very important that therefore to have a lower shrinkage, and this is not possible in this standard way of producing the filaments. You can see here the shrinkage that we have is over 15%, and we can get it lower to 10%, but then also the strength of the yarn lowers significantly. So what we are doing now is do it in 2 steps. So this is again written into the CWA, really the process of how to produce these bio-based materials and how to create stronger and better bio-based materials in composites. In the POY process, we are not fully drawing the yarn, but we are only using melt drawing in this step. So only one roll and one relaxation roll. So the polymer is still in its well state and no crystalline structure yet. We do it at very high speeds, up to 3,000 meters a minute. And then in the second step, we use these POY yarns and we stretch them again into ovens. So we heat these up again, ovens or rolls, both of them have been tried. We heat them up again to really have the solid state drawing as well. So both of the types of drawing we are using, and then you can see here in the image the strength that we create. So the tenacity centinewton per text, we create up to 50 centinewton per text. With the standard FDY ratio, we only have around 35, sometimes up to 40 centinewton per text. So much higher strength, but also, and this is the main important one, the shrinkage that we want to lower from 20% to 10%, even ideally 5%. And you can see here with some of them even reaching the 8% mark. We have done 2 different types of shrinkage method, but the orange one is the most important to look at. And there we can see that we almost reached the 8%. So going from 20% to the 8% mark, while also increasing the strength of the yarns. So this is what it was written also into this CWA.
Okay, thank you, Robbie. Yeah, the idea was for you also to show you one CWA, how it was being done, and then later we will maybe try to have some feedback about this. So Katja, if you can show also yours standards that you that has been done in the BIO-UPTAKE project.
Okay, can you give me permission to share?
Yes, Thibaut will give you the permission.
Yes, it's working.
Okay, I'm not sure if you see my screen. Yeah?
Yes.
Are you seeing?
Yeah, it's
okay.
Okay,
because I don't see, I only see your faces, so I will follow up. I hope it goes well. So my name is Katja, so I'm from the University of Aveiro, and I'm here on behalf of Professor Isabel Lopes, and I will present now the Q&A on the technical and ecotoxicological analysis of these bio-based materials that are being developed within the BIO-UPTAKE project. So this transition to a climate neutral and circular resource efficient economy is, as you may know, the central pillar of several European frameworks.
Sorry to interrupt. Can you, you don't share the right screen? Yeah, yes, here.
Yeah, it's moving. No, I cannot present it in sharing mode. Ah, now it is. Okay, sorry. Probably it's my computer that was a little bit slow. Now you see the second slide, right?
Yeah, perfect.
Okay, nice. So as I was saying, so the central pillar of the European strategies frameworks include like the European Green Deal or the Green Industrial Deal. And these regulatory initiatives, such as the Eco-Design for Sustainable Products Regulation, the forthcoming Digital Product Passport, or even the European Net Zero Industry Act, are actually driving unprecedented demands for the robustness and verifiable sustainability evidence. And in fact, the European Union's product and industrial policy package is built
directly on chemical safety foundation established by REACH and ECHA, for instance. These legislation have provided us so far product chemical hazards and transparency, regulatory controls, product performance and information requirements, and of course traceability of these same materials. The main targets for these regulatory frameworks are to design safer materials that are not only compatible with the environment, since we are intending to achieve zero pollution targets for air, for soil, and for water, as well as safe for humans. And in fact, this may be done at the starting point of the materials development, instead of only at marketing or after marketing time points. And this is increasingly important since industries are increasingly targeting for the requirement of the eco-label seal of the European Commission. And in fact, this seal is important to say that is also becoming more appealing to the consumers. And however, given this vast number of existing regulations, of course, industries are facing increasing challenges in evaluating this eco-compatibility of the materials that are being developed. And of course, identifying the most relevant guidelines and performing the corresponding tests often is not only time consuming, but it's also resource consuming. So we are talking about money, of course. Beyond this regulatory complexity, there are also some constraints related to the speed of the European Union sustainability transition. So this proposed cure that is being developed between ILENA and the University of Aveiro aims at providing the companies or the industries with a simplified and practical industry-friendly roadmap for the characterization of the freshwater ecotoxicity of these bio-based materials. And this approach not only would enable materials and products to be validated against environmental requirements for marketplace, but are also targeted to be simple and fast in time, if I may say like that. So the QA has addressed three main aspects that relate with the type of material to be tested, the sample preparation method that must be appropriate to the material that is being tested, and of course the design of a battery of freshwater assays that are not only representative, but are also sensitive and, as I said before, cost effective. So regarding the type of materials within the BIO-UPTAKE project, we have identified 4 types of materials. So bio-epoxy resins, bio-based fibers, bio-based pellets, and bio-based intermediate products. And for each group of these materials, the samples to be tested in the organisms had to consider some specifications. So in the case of the resins, for instance, they change properties upon exposure to air. So this means that opening of a resin flask must be performed, for instance, under an agar atmosphere to prevent the premature hardening due to oxygen exposure. For instance, we found this the first time when we opened the resins under the environment, and we found out that 2 weeks later the resins have hardened, and in fact they have changed the color. So this means that they are changing their properties. Also, when preparing, for instance, stock solutions for these resins, most of them are insoluble in water. So the first step is to dissolve them in a polar solvent such as DMSAO at the lowest concentration necessary just to fully dissolve the resin, and then prepare the subsequent concentrations using this stock solution with the appropriate media that we use for each specific freshwater species. For the remaining formats, we have performed 24 hours liquids or elutrate suspensions that were prepared to mimic potential release of contaminants or nutrients from these solid materials into a liquid phase. For the bio-based fibers and for the bio-based pellets, We have followed the available German standard method for the examination of water, wastewater, and sludge that indicates that these materials have to be deployed in distilled water at a proportion of 10:1 in terms of volume weight. They are left to stir for 24 hours at room temperature, after which they are filtered by a 0.22 micrometer membrane and then are diluted according to the desired dilutions that we want and using media proper for each freshwater species. With regard to the bio-based intermediate format, we have followed also a standard that is already available, which is the technical specification published by SEN, described for the procedure for preparing liquids. In this case, small squares, 1 centimeter squares of each of these intermediate format materials are deployed in distilled water, in 8 milliliters of distilled water, and are also left for stir for 24 hours, after which they are filtered, and then the dilutions are prepared according to what we need. In this case of the bio-based intermediate formats, as they were the closest to the end product, and the 24 hours leaching period, we found out that it was not very relevant in terms of environmental realism. We have also done some medium and long-term leakage assays that were left to stir for 32 and 64 days respectively. So after all these, all solutions, eluterate and liquids are proposed to be tested using an array of freshwater organisms, and these organisms are selected based on their sensitivity, the availability of also standard guidelines, and of course their trophic and functional representativeness in the environment. For instance, we have a green unicellular microalgae, a macrophyte that has a systemic exposure pathway, and both these organisms are included in the producers group. For primary consumers, we have included the Cladoceran Daphne magna and the Rotifor Brachianus caliciflor, while early life stages of the freshwater fish, the Euchario, are representative of the secondary consumers. We believe that this integrative ecotoxicity assessment is essential to provide validation and ensure regulatory compliance and eco-compatibility with the safe and sustainable by design framework that has already been mentioned. This SSBD framework is volunteered and it's tiered and targets the incorporation of these bioassay batteries as part of the overall hazard assessment. And we believe that this may guide innovation towards safe and more sustainable products from earliest stages of development. So this QA is proposed to be an harmonized, interoperable, and simple method for rapid and sensitive screening of these materials, enabling industrial partners to apply it efficiently. Thank you.
Thank you, Katia. So with these last two examples, we wanted to show you how it looks like, some CWA or QA. And just, I think because we're running out of time, we won't do the roundtable as we wanted to do it. I will have just one question maybe for Robbie, because you have done the process of making the standards. So how it went and what was your feedback about it? What did you think about it? Is it useful for you even after the project? Just if you can tell us a few words about it.
Yes, so I think the CWA is a very interesting way because we had some nice results, some new things that we showed, and I think it's an interesting way to showcase this as well, to have it as like a baseline, and then the knowledge can also be shared and used and be expanded on by us, by maybe also other people. So I think it's very interesting. The way it was written was quite nice as well, I would say, because we had a deliverable in BIO-UPTAKE, which actually formed the basis to be written upon for the CWA, and together with Elena was quite helpful to really have some constant feedback and ways to write the deliverable. Then we also had some meetings with a lot of people could freely join these CWA meetings to give us feedback on this CWA. So I think it is very interesting and helpful. If it could be helpful, definitely for us as well, even after the project. Okay, great. Thanks a lot for your feedback. I think now with the time we will go through the last session led by Nicolas.
Yes. Yes, as Nicolas said, we won't be able to manage the roundtable we expected, so we propose to switch directly to the last session, the interactive session. Just before letting the floor to Nicolas, I propose you to connect to Mentimeter, our tool, to our interactive tool, to ask you some questions. Okay. Do you see my screen? Okay, that's working. I'm also sending you the link in the chat for all the participants. So just a few seconds to connect to the session. You will be able to maybe to answer to the first question, I think, and then after we will switch to another questions. Okay, 5 seconds. And Nicolas, I let you the floor to introduce this part and the MNLT. Okay. I think it's working for you now, Nicolas. Just confirm to me.
Okay, I think we need a bit more time for the Mentimeter for the code.
Okay.
Is anyone connected? Just give 10 more seconds. Okay. Can you see my screen?
Yes. Yes. It's working.
So you see the presentation?
Yes. Yes, it's in presentation mode.
So good morning to everyone, and welcome to today's interactive session on standardization. Standardization is a practice which not only benefits the end user, but also the producer. So the standardization is a necessity for ensuring, let's say, the competitiveness of the product in the market, adhering to all the legal, safety, and quality standards. So through the standardization, we can reduce the cost of the product, and we can also simplify the production process. So the aim of the interactive section is open up the discussion, let's say, for the standardization. For this, we have prepared a questionnaire. I'll get into details about this. First, I would like to also introduce ourselves. So I'm representing MNLT Innovations. I'll try not to take much of your time. So MNLT is a spin-off of Monolithos, which leads the innovation on catalysts, on production of catalysts and recycling. We are doing a lot of business and planning analysis on different projects, from artificial intelligence, from THERMOFIRE also is one of it. And also we are performing life cycle analysis, which is, I think, quite important for the goal of sustainability. So we're developing strategies for the commercialization of the different ideas and technologies, and also, as I said, the life cycle assessments for economic viability. And also we are trying to establish long-term partnerships, which we think it's important to having a connection from the bottom, from research institutes up to industries. And our role in the THERMOFIRE project, can you see, sorry. It's actually, first of all, to develop an exploitation strategy and also an IPR management strategy for the project, and also to evaluate the standardization progress and verify the landscape. So with this said, we will proceed with the questionnaire. We'll share a questionnaire and you have more or less 5 minutes to answer the questions. It's a multiple choice questionnaire. We'll try to then analyze the answers and open the discussion for its answer. And with this, we can proceed, I think. Let me see. So we give some time.
Just a reminder to connect to the platform. I also sent the link directly in the chat. And also to have more feedback, because we will send, of course, this question to all the participants after the workshop and to our networks, of course. Okay.
Sorry, I can open, but I can't put my votes.
Not yet.
It has not started yet. So
Okay.
When I will click on this button, I think you will have the first question. Okay, let's begin. Okay, I think it's appearing for you now.
Yeah.
Yes.
Okay, for those who have not joined us yet, you still can click on the button on the link in the chat. Okay. Can we switch to the next question? If you have any issue for participants, don't hesitate also to ask us questions directly. So how familiar are you with the standardization activities or processes? From very familiar to not familiar. Logically, after this webinar, we have a basic understanding of standardization, at least.
Yeah, I think the information provided by Elena, at least for me, was not previously understood. So yeah, this kind of information is very appreciated.
So regarding this question, also a basic, it can be one aspect. For example, it can be if you have any engagements with any standardization committee, for example, ISO or CNN, or if you have identify the landscape of the standards, existing standards, let's say, as some projects, let's say, refer previously. So these are some criteria.
Next question. So which standardization challenges must affect the development of adoption, sorry, of bio-based composites? I don't know, Nikolaus, if you want to comment the several answers. But...
Yeah, I can comment. So yes, here actually we want to identify the bottlenecks, let's say, that slow down innovation and market deployment. For example, the lack of unified terminology is one of them that creates confusion amongst project industries and regulators, let's say. Or another thing is missing testing methods, as some also colleagues refer, which makes it possible to compare the results, let's say, of certified products. Or another issue is slow standardization procedures. Innovation normally has a faster pace, so it's an inherent, let's say, issue that the standardization procedures are slower. And also another thing which is quite important is unclear industrial or market requirements. For example, in our case that we are developing bio-based composites, it's quite important at least to have some recycling standards. To know, for example, what material consistency we can use.
Just don't miss to click on the submit button on your screen. Do we switch to the next question?
Mm-hmm.
So which stage of
for
the
this question, which stage of the innovation?
Go ahead, sorry.
Can you hear me?
Yes.
Sorry, no words. So for this question, which stage of the innovation chain faces the greatest standardization gap? Here we want to understand where the life cycle of bio-based composite development standards are, let's say, lacking or they are unclear. For example, in the research phase, we might lack terminology or some early testing guidance or some other harmonized protocols, let's say. And then, for example, in the scale-up prototyping, we may lack some characterized, let's say, validation methods. And in the stage, for example, of market validation, sometimes we see that we're missing some certification routes. So we want to see which phase, let's say, based on the participants is more, let's say, there's more lack on standardization. Also, end of life is another important aspect.
Okay, a few seconds before switching to the next question. Most of the answers are toward the research and early development or market validation. Okay. Let's switch.
So the next question we have, the type of the support would be the most useful to help your organization navigate standardization. One is mapping of the relevant existing standards. The other one is the identification of gaps and needs, then guidance and engaging with ISO committees. And then also access to best practices from EU project. So I think it's important to have relevant workshops, let's say, exchange ideas and best practices.
Okay.
Will we go later, question by question?
Okay.
Okay.
Okay, next question.
So here we have the areas of standardization that should be addressed in order to support market uptake of advanced bio-based composites. So we need actually to prioritize areas where a coordinated effort would be have the biggest impact, for example. One sector which is quite important and fundamental one is material characterization. Then we have sustainability, which goes hand by hand with the material characterization because we're developing materials that are bio-based and are aiming for sustainable applications. And we have fire and safety performance, which is sometimes is the regulatory barrier, let's say. Durability and aging protocols, end of life and recycling methods, quantification methods for bio-based content. And then also we have digital product management, which is an emerging, let's say, but key for future, let's say, regulatory systems.
Okay. Let's switch.
So here we have the format that would most improve the knowledge transfer among stakeholders. This actually means what's more important: technical workshops, knowledge hubs, coordination meetings, co-authored guidelines, or early involvement, for example, of standardization bodies. For example, a workshop like this, I think, it opened the floors for different parties to come into collaboration from standardization, industry, and research institutes. And for example, another thing would be a more permanent knowledge hub, which, for example, industries could give feedback for the recyclability of the products to, let's say, the requirements to the institutes that actually develop the technology and the materials.
Okay. I think we can move on. It's perfect. Few seconds.
Mm-hmm.
And the next question will be the last. If I'm true.
So here we have the last question about the most important factor, let's say, for accelerating the adoption of advanced bio-based composites in industry. We want to understand what industry and researchers actually perceive as the biggest lever, let's say, for the market uptake. So this has to do, for example, with performance of data, which builds trust, let's say, for the end users and also for the industries that are going to produce the material. Then clear standards and certifications in order to reduce risks for manufacturers if they are going to develop and substitute classical polymers with biopolymers, for example. Then we have policy or regulatory institutions with lower costs, with lower production costs, for example, is crucial for competitiveness. And also, it's important to know the market awareness to influence the adoption in more, let's say, conservative sector. And finally, the improved sustainability evidence, which is also goal of the products, the bio-based products.
I think it's okay for that last question. I don't know, Nicolas, or do you want to maybe to conclude this this questionnaire?
Yeah. So to conclude the question, first of all, I want to thank all the participants and also Mr. Gallo for participating and give us the insights, let's say, about the standardization procedures. I think what all speakers and from the questionnaire we saw is that the missing standardizations, protocols on fire retardant or bio-based products. We mostly could find standardization protocols about classic polymers, meaning petrochemical polymers. And also we are missing standardizations on recyclability. So I think it's important to build the connections between industry, innovation centers, and standardization. And for example, here we see that most people answer that the area that should be addressed is end of life and recycling methods. Before, for example, Mrs. Villaro said that in our case, in the THERMOFIRE project, we are using fire retardants that are not 100% recyclable in order to reach, to face the demands, let's say, of the project. So for this, it would be really useful to have a connection with end users and industry in order to know the exact content, let's say, that we could use, the limits of this. So, for example, it would be useful to have hubs that the different organizations would communicate and collaborate in order to develop the standards for the contents, let's say, of a composite material. Because in the nature, by its nature, developing standards for the composite materials is difficult. And of course, we are trying to substitute materials that are on the market for, let's say, polymers for many years, let's say. So this is a procedure that goes a slow procedure, and we want to know what limits we have, what composition we can use. So here again, we see that most people answer that there's a gap on the needs and the identification. So I think it matches what I referred before about the landscape of the standards in the in the bio-based composites and also in the recyclability. So I think in order to strengthen this, again, technical workshops, hubs, and coordination meetings are important, I think, for the future of the standardization.
Okay, thank you, Nicolas. I think we are out of time. Now we have to conclude this this webinar. Thank you very much, Nicolas, for the moderation of this last session and workshop. We'll share this questionnaire in our network from Polymeris and to all partners, and of course to all projects, to have more feedback than that we had in this webinar, of course. Just to conclude, I would like to thank all of the participants for joining us today, for participating to this workshop, and of course many thanks to you speakers and projects for accepting to join this initiative, and for the quality, of course, of your presentations. The presentations will be shared to the participants if the speakers accept, and the webinar, of course, has been recorded, so you will have the access to the replay after the event. If you have any more questions, of course, feel free to ask to the speakers or directly to me, and I will send the questions to each project. And finally, to close this webinar, thank you, and have a nice day, and see you soon.
Thank you.
Thank you very much. Have a nice day, everyone.
Thank you.